This is Roshan. Please confirm if I'm audible and everybody can see my screen. You can give me a thumbs up or yes in the chat. Uh,
Yeah, we are able. Yeah.
Good. Or you can unmute yourself and speak. Thank you so much. OK, so let me get started. So before I get started, let me introduce myself. My name is Roshan. I'm with Isha from last 4 years. I take up multiple courses. I take up SRE course and AWS course, DevOps course with multiple educational institutes like ESA and Intellipath, Edureka, Simplilearn. If you have heard of all those institutes, I take up trainings there. This particular training is we're gonna focus on uh, microservices, Docker, and Kubernetes, and along with when we have the applications deployed in Docker and Kubernetes, the monitoring part using Prometheus and Grafana, right? So what I'm gonna do, the agenda for this demo session is to make you aware what this course brings to the table, what value it will add to your skill sets, to your knowledge, right? And then you can ask me question. I'll talk about the course, and then you can ask me questions. So this is going to be the demo sessions, and we have tomorrow the day one. We're going to start this. Whatever we are talking about, we already have people enrolled already for this, and we're going to start. They no wait time in for this particular course. You need to take a decision. Tomorrow you can join, kind of a, but you need to decide at the earliest. OK, so let me get started. Before I get started, let me introduce myself. So uh, Roshan, I am having 16 years of experience in IT. Started my career as a Java developer, and then I have been into multiple technologies like DevOps and SRE. I'm currently working as a principal SRE with one of the uh, world's biggest giant retailer. OK, uh, and I've worked on multiple cloud service providers, AWS, Azure, and GCP. I am DevOps and SRE consultant, right? And on my hobbies, I love to travel and share my knowledge. That's all about me. OK, so let me get started. People are still joining. Let me accept. OK, so about this course. So what this course brings. So first of all, you know that we are living in microservices application. Wherever you see, we have not talking about nowadays about monolithic applications. We're talking about microservices applications. Does anybody know here what is microservices and how different it is from monolithic applications? Anybody? Feel free. Let's have this interaction going, and we'll make sure that you have this 1 hour worth. You'll have some learning. So anybody would like to say what is microservices and how different it is from monolithic applications? Anybody would like to try? So no idea? No problem. OK, see, to understand microservices, you need to understand about monolithic. So what I'm going to talk about, let me share a GitHub. I'm going to, it's going to be easy. I have drawn this earlier. So let me share one image with you. And with that image, we're going to understand things better. Second, OK, just give me a. OK, just focus on this particular image, what I'm seeing. So what I'm showing you is on the left side is 3-tier application. The web server, usually like the application that we work on is usually we have 3 tier: web server, app server, and database server, right? Web server is what you see when you hit any website, Amazon.com. What you see is coming from the web server, web pages, web content, whatever you see is coming from the web server. And then when you do some operations on the web, right, it hits the request goes to the application server where the computation logic happens. And then if it requires information to get from database, it connects the database. Like that's how the 3 tier architecture works. Web server, request goes to application server, and then for records, for information, the request goes to DB server, it gets the information, and then the user gets the display. It could be any book my show, right? You can you can book your tickets. The tickets after you book, it goes to the database. Then later, if you know your ID and all whatever, you can go to the orders list and you can get display. All those information that you see is coming from the database. Whenever you book a ticket, information go to the database. That's what the 3 tier application looks like. It could be your Amazon website. You go to the websites, you do shopping. It has the competition logic, and then it has a lot of information in the database. When you do an order, the information gets stored in the database. Even if after multiple years, you can go and check your order ID because it's stored in the database. Usually any application, what you see, Swiggy, Ola, Uber, Flipkart, based on 3 tier application. So what I want you to focus on is on the application server. When you focus on the application server, what do we have? We have the modules, the code, the logic, right? The most of the logic is in the application server. That's all the logic is in the application server. So what I want you to imagine a lot of code into it. Let's split let's say if I have a Flipkart application or any e-library application, I may have a lot of functionalities, right? Let's say Flipkart. I have, or let's say Make My Trip. I would take this example, Make My Trip, right? So let's say Make My Trip has a lot of features. It has option to book flights. It has option to book buses. It has option to book trains, hotels. So consider those as different modules. Different modules. So I'm calling it M1, M2, M3, M4. Usually what these modules have, they have the code functions. They have the functions. M1 has got, let's say function F1 to F20. Let's say M1 has got 20 functions. For example, M2 has got, again, let's say 30 functions, F21 to F50. Right? M3 has got some functions, let's say 50 functions. M4 has got, let's say 200 functions, right? 100 functions. Let's say that's what the modules has. When I say module, I'm talking about all the logic, right? Let's say Make My Trip. I'm talking about when you go to Flipkart, you have a lot of code into it, right? Written. What you see is the web page. But when you click something, when I give some source, destination, date, when I click on search, the information goes to the application server, then it goes to the database server, right? Those kind of information I'm talking about. And you have got a lot of features, other features also here, a lot of things displayed. So I'm talking about all the functions for the module perspective, right? I'm talking about that. So when you have all the functions located in one application server, packaged together, we call it. When you have all the functions of all across all the modules packaged together, that is called monolithic. When I say packaged together, you need to understand from a technical perspective. What does it mean from a technical perspective? That I can call, let's see, if I'm writing function for F1, let's say if I'm writing F10, I can call any other functions from any other module. So there is a huge dependency across all the modules, right? That's what I'm talking about from a technical perspective. When I'm writing F5 or F10, I can call any other functions across any other modules. Huge dependency. So M1 depends on M2, M3, M4, M3 depends on M1, M2, M4. The huge dependency. We call it tightly coupled. So what is the problem with such monolithic applications? When we understand this monolithic, then only we can understand the importance of microservices. We can understand the importance of Docker, Kubernetes. That is the inception. We need to understand this part. So what is the problem? What do you think? What could be the problem with such dependency? What do you think of? Any problem? See, when a dependency happen, right, what happens? Let's say if I have issue with one of the functions in M1, let's say F5. F5 is a part of M1. Let's say I have some issue, some bug. It will definitely impact M1. It will not, the M1 would not function as it's supposed to be. Now, since I have dependency, do you think it can impact M2, M3, and M4 other modules? Because since I'm calling the modules, I'm calling the functions across all the modules. There's a huge dependency. The functions are being called anywhere and everywhere. Do you think that issue with one of the functions can impact the other modules, and it could bring the application down? If since there is so much of dependency, can that happen? Yes, no, definitely. When there is a problem, when there is a so much of dependency, this will happen. And that is what we are talking about from a microservices perspective. And that is why we need to make this guy independent. M1 independent, M2 independent, M3 independent. I don't want to call the functions. I want all the functionalities. But I want to remove the dependency. The dependency is the problem. Packaging together is the problem. The code getting packaged together is a problem. I want to split the functions. I want to make each module independent. I don't want to call the functions across. If I'm writing a function for M1, I don't want to call functions from other modules. That's how I can remove the dependency. So that's what microservices brings to the table. So microservices talks about making micro modules independent, loosely coupled. These are the words we use here. Here it's tightly coupled. The functions are being called, functions from the modules are being called anywhere and everywhere. Here, I'm not calling the functions. Do you know about API, guys? API, have you heard of API thing? Get call, post call, put call, delete call. Anybody? Anuman has heard. So that's what we will make use of. Mahadev has heard. Good. See, when I am creating M1, I will write functions, but I'm not gonna call other functions from other modules while writing M1. No, the functions can call within M1. That's fine, but not across the modules. And if M3 needs some information from M1, they will call the API. For example, when I click on, let's say, search Delhi to Bangalore, right? Let's say I get some flight information, right? So do you think Make My Trip owns in Air India, SpiceJet, Air India, like all the data Indigo database? Does Make My Trip all owns all these flight carriers? Do you think so? And why this information is coming? I can book the tickets. The Make My Trip calls the API. Indigo, Air India, they have exposed APIs. They have given Make My Trip has purchased or Clear Trip has purchased APIs from these flight carriers. That if I want, it's a business for them, right? Win-win situation. They have created the endpoint API and they have shared those API with this Make My Trip or Clear Trip, right? Any other websites like that. And they call the API and get to get the information. They don't own the database. They don't have database access. Make My Trip. Make My Trip doesn't own any of these flight carriers. They don't have database access. Make My Trip doesn't have access at all. So how this kind of communication happens through API. So similarly, right? If I need some information, if M1 needs some information from M3, I'll call the API. That's what, right? So that's what it matters when I am going across hotels or homestays. These are my modules, different modules. If trains need some information from other modules, I'll call the API. I'll not put the code together. It's all about technical aspect. Putting the code together or independent or separate. So in the case of microservices, it is independent. The modules are independent. What what value it will add? If M1 has some issue, will it impact other modules here? In the case of microservices, if M1 or one of the functions of M1 has some issue, will it impact M2, M3, M4? Yes or no? Will it impact other modules? Issue with one of the modules, one issue with one of the functions of one of the modules, would it impact other modules? Guys, I cannot see your head nodding no or yes. Need somebody to respond in a way that I can understand so that I can proceed. I want to make your 1 hour worth. So help me do that. Are we on the same page, everybody?
Yes, sir.
Right? So it will not impact because dependency is not there. That is where we talk about microservices. So the questions come. Next question. OK, are we clear on this first part? Monolithic versus microservices? I hope, right? You guys have answered it. Feel free to interrupt me, unmute yourself and ask me questions. The second part, where should we deploy this? That's the part. So because we are putting a lot of code here, we need to deploy the monolithic. We deploy monolithic application on the VMs, virtual machines, VM. We deploy on VM. Now, where do we deploy the microservices? We deploy them on containers, right? That is when the Docker comes. So Docker, what is a Docker? Docker is a software which helps us create containers and deploy microservices. That's what Docker do. So think about, so we deploy, correct, Jasankar, that's what, because so first you need to understand what is VM and what is container. You need to understand that part first. To answer this, to understand this question, you need to understand. OK, do we all agree that this monolithic server, app server, has got a lot of code, bigger code base, and M1 has got lesser code base as compared to the application server? Yes. You know, the center, the entire thing, all these containers, Docker, Kubernetes, right? It's, if you look at the center, why do we have this popular thing? You'll understand that it is cost. Because where do we create containers? Do you know? We create containers on the VMs only. We split the VM. We create multiple containers on the same VM. I can create multiple containers on the same VM, same infra. I can go to the cloud. I can create EC2 instance, 2 core, 4 core, 8 core. I can use that instance to deploy this complete application server. And I can use some lesser core VM to deploy all the microservices. I can create containers. So we create containers on the VM only. It takes very less core, very less core. See, it has been observed that when things are deployed on VM, the resource utilization is like 10-20%. We are not able to utilize the resources of a VM better by creating containers on the same VM. Like we can create multiple containers on the same VM. We will make sure that the VM utilization, infra utilization is properly utilized. Properly utilized. To give you, to deploy this 3-tier application, I require 3 VMs. Are you on the same page? You require 3 VMs, right? App server, web server, database server. Yes. I can take one VM and deploy container for web server, container for app server, container for database server in one VM itself. If I go by the container technology. So it's a technology we are talking about. So we split the code, bigger monolithic code to microservices. And then what did we do? We created containers on the same VM. So on the same VM, right? So this is the most important part. If you understand this, right, that is when you will appreciate the importance of Docker and Kubernetes. What value it can bring. Let's say if I have this VM, in this VM, once I install Docker, Docker is a container engine. Docker. What is Docker? Docker is a container engine. Understand this. Words, very important. This is from the fundamental, guys. Just focus today and your fundamentals will be clear. That's the value addition for you from 1 hour, okay? So Docker is container engine. So we will, this VM, you know, every VM has the OS. Do we all know this? Do we all know this, that every VM will have an OS? Let's say this VM has the OS, Ubuntu, Red Hat, Amazon Linux, whatever, Red Hat, whatever. I'm going to install Docker, a container engine on this VM. OS was already there. I've installed container engine, Docker. And then what happens? I can create containers. I can create containers, multiple containers I can create in the same VM. If I need, I can deploy one web server, app server, database server, or if I have split my application server into 4 microservices, I can deploy that as well. So overall, I will utilize the what I will achieve? I will achieve the efficient utilization of the resources, and which will impact my cost. Cost is at the center. You need to understand this. Technology is only appreciated when it saves the cost. This is a truth. Virtualization. Why virtualization was so popular? Earlier, we were deploying things directly on the physical server. Then around mid 2000, virtualization came. We installed a virtualization software on the physical server and we created VMs. It was a revolution because we were able to utilize it better. Now it is that revolution. Again, this revolution is happening at the VM level. We're going to install a container engine on the VM and we can create containers, multiple containers, and we can have different containers. I can have a container for web server. I can have a container for database server. All we need is the image. OK, we can create it. I'll not go in detail for you to get confused. I'll not go to that level today. I just want you to understand the why we are talking about this term. What is microservices? What is Docker? So what is at the center? Why? What is the driving factor for all this technology? If somebody would ask you, what is the driving factor? What would you answer? Cost. Cost optimization. Cost optimization. Technology is only appreciated when it saves some cost. Cost optimization through proper through efficient infra utilization. Earlier, we were without this technology. Let's say if I require 50 VMs, 50 VMs of 4 core each. So totally I have got 200 cores, 50 VMs of 4 core each. So I require 200 VMs. Trust me, with this technology, people have reported that they could achieve the same load, same scalability performance with 50 cores. Because earlier the resources were 20% utilized, 10% utilized. People were having just bigger VMs. And they require multiple VMs for high availability. Now, if I do this technology, I can achieve the same thing in 50 cores or 100 cores, 50% of the cost reduction. Okay. Did we understand this? First of all, why we are talking about what monolithic and microservices? That is again on the high availability. So don't get confused with that. So this is separate thing. This is from a application availability. Why I'm doing this? Because I don't want to take a risk. If issue with one of the function, I don't want to bring the entire application down. I want to make it independent. This is from the application reliability and management, right? If I have 4 different modules, I can work separately. I need not wait for a bigger quarterly release to happen. All the code. If I'm making changes in M1, if I want to deploy the change, I have to deploy everything. In the case of monolithic, but in the case of microservices, I need to only focus on M1. So this is from the application reliability. So this is another story, monolithic to microservices, but the story gets very interesting when you deploy this microservices on the containers. That is what the latest thing is going on. We deploy. So it's not like we cannot deploy microservices on the VMs. We can deploy. Microservices is nothing but a separate piece of code, some smaller code base, independent code base. That's what. Earlier I was having 500 functions total. Now M1 has got 100 functions. Or 125 functions, whatever. I can deploy M1 in a VM, but again, I don't want to do that because of efficient utilization of the resources. So that is when we're talking about Docker. So in this course, guys, we will talk about these things. We'll talk about what is microservices, right? What is the difference we already covered? Containers. Again, tomorrow, again, I'll start from scratch these things. Then what is Docker? Why we are talking about Docker? Because Docker will help us create containers. How will it help? That we will see hands-on. How it will create containers, how it will deploy microservices. How could we create containers on a VM? And we'll discuss about Docker Hub and a lot of Docker volume, Docker Compose, Docker files, a lot of things in this course. Now, why this Kubernetes then? So the difference between Docker and Kubernetes is one is container engine. Docker is container engine. We need Docker to create containers. Docker is container engine. We need this guy to create containers, to deploy microservices on the containers. Docker it's a software we will install on a VM and we can create containers. But that's not enough for production systems. Now tell me one thing. I'm going to ask you, you will only answer this, okay? I'm going to simply ask you a couple of questions. In production, do you think so it will help us create container, okay? So what it will do? It will help It helps create containers and deploy microservices. Okay. Now, Kubernetes. Now, do you think that in production, if a load increases, do you think if I have some mechanism using which containers also gets auto scaled, will you like this idea? If a load increases, containers also gets auto scaled. Will you like this idea? To accommodate that extra load, containers gets auto scaled. Let's say I have got 100 TPS load and I have 5 containers. If let's say all of a sudden 200 TPS came and automatically the containers got increased double. Will you like this idea? Will you like this kind of a setup in production? Or you want somebody to look into the load or get some high response time, then manually somebody should scale up the containers? What do you guys think? Auto scaling or manual thing? Guys, it's simple. I need you to. What do you think? Auto scaling? Good. So people are Wahid Rahman is saying auto scaling is important. So auto scaling of containers. Good. No? If I have got more containers, do you want the load to get balanced across all the containers? Containers should take the load, right? Auto load balancing of request across the containers. Do we need this feature? Okay. Yes. Good. Let's say if a container dies, let's say I have got multiple containers. Let's say one container dies, some issue happened. Would you like if that containers auto heals and creates a new container automatically? Some issue happened and that container died. Let's say consider that. So consider container as a process right now. If you don't understand container, what is it? Consider container as a process. If a process dies, would you like if that process auto heals or comes up automatically without manual intervention? Will you like this idea? Will this kind of a situation technology? Would you prefer to have your such kind of technology in production where we're supposed to maintain 24/7 high availability? We don't want downtime at all. Yes, auto healing. Good. Now let's say this container is having some V1 image, some binary, some software version, because at the end it's microservice, right? It's a code that's running in the container. And let's say developer has some changes. He has a V2 code and he wants to deploy the latest code. Has done some bug fixes and he wants to deploy the latest code V2. If the new code gets deployed without downtime, without bringing things down, will you like this? This container is there. This container is having V1 code. I want this V1 code to get replaced by V2 code or some enhancements. So what is the option? I have to bring this down and then bring the another container with V2, right? But what if I have a technology which creates first a new container, with V2. When this is up and running, then it deletes V1. Would you like this kind of a solution? First new kernel will come up and then it will get killed. So I will not have a downtime. And I got the image also upgraded. Right? That's called auto deployment. So guys, all those features that I'm talking about is not the feature of Docker. Docker doesn't have all these features. Auto scaling, auto healing, auto load balancing, auto deployment. No, Docker doesn't have all these features. What Docker does? It creates container and deploy microservices. Do you know who gives us these features? Who can provide these features? A container orchestration engine. Docker is just a container engine. A container orchestration engine provides these kind of features. Container orchestration engine. And do you know what's the most popular container orchestration engine in the market right now? It is Kubernetes. We call it KATES. Now, this story is interesting. So with Docker, I could create containers, deploy microservices. That's great. But I need these features also. So why can't use a container engine with container orchestration engine? So container orchestration engine uses container engine. That's why Kubernetes is the most popular thing right now. Because think about it. If you are using Kubernetes in production, how reliable your production will be? Everything is sorted out. Auto scaling, auto healing, auto deployment, auto load balancing. Everything is sorted out. Are we on the same page? What is the importance of Docker? What is the importance of Kubernetes? Hanuman has got a thumbs up. How about others? Wahid, good. Others? Good. Jasankar, Mahadev, good. Ajita, all good for you? Okay, silence. I take the silence that okay. That is why we are talking about all these things, guys. It's about high availability, zero downtime. That's what we want to achieve for customers in production. And that's why these technologies. Now, once we have everything deployed, so what do we have in Kubernetes concept? We will learn about Kubernetes, what it is, architecture, and we will take this demonstration of everything. Everything is hands-on, guys. I'm going to demonstrate all these things. Creating containers, images, Docker files, Docker volumes, Docker compose, then Kubernetes cluster. We will talk about EKS. We'll create EKS. We'll create EKS. We'll demonstrate using EKS. Elastic Kubernetes Service. It's a managed service of AWS. And we'll learn Kubernetes. Auto scaling we'll learn. Everything we'll learn. All these concepts, whatever you are looking at. Full-fledged course. So once we have everything deployed, our application, our microservices running in production, what do we need? We need to know the health, how they are doing, how their response time, how their CPU, how their memory, how they're doing in production, how we can capture those details with monitoring. That's when the last topic comes, and we'll talk about monitoring. Kubernetes monitoring using Prometheus and Grafana. So that's what this course will focus on. Dedicated focus on this. This is what, and it's going to be a 20 hours of course. Everything is hands-on. I'm going to share these PPTs with you. Container orchestration engine, Docker. First of all, let's talk about container engine Docker. I'll talk about each and everything. What is VM, physical servers, virtual servers, containers? What is containers? How do we create containers? There are other container engines like Rocket, but we'll talk about Docker. What is Docker lifecycle, Docker architecture, installation, commands, Docker file, Docker volumes, Docker compose. Everything is we're going to talk about, right? Then we'll talk about container orchestration engine, Kubernetes architecture. Why are we talking about Kubernetes? COE features. Why are we talking about Kubernetes? What problem it solves? The architecture, Kubernetes architecture. This is the architecture. We'll talk about it. I'm going to save these PPs with you. Then talk about EKS. We'll create EKS cluster and we'll demonstrate what is pod, services, replica set. Everything is hands-on. We will see things being done, and that's what we'll learn. Then we'll talk about monitoring part. We'll talk about auto scaling also, HPA. A lot of slides, 100 slides are there. It takes a lot of time. It takes approximately 10-12 hours. A lot of time. 100 slides we have here. Then we'll talk about monitoring. What is Prometheus-Grafana? What's the architecture of Prometheus? How do we install Prometheus? How do we install Grafana? How do we capture metrics? And that too in Kubernetes cluster. So we'll use Helm chart to install things. So this is what this course will focus on. This is all the things will be shared, all the commands will be shared, everything will be shared. You'll get comfortable with all these things. You can ask any questions, guys, if you have. Yeah, go ahead, Jason. You can unmute yourself.
Yeah. So, thanks, Roshan. I have a question. Whatever you just said right now in terms of Docker Kubernetes is on in relation to a particular application, correct? How it works and how it goes down. So
Correct.
What will be the hands-on that we are doing? We're just going to create few Dockers and do it, or is there a project type setup where you're going to take some sample items?
See,
and,
we will
how
deploy
it works?
application. Yeah, I got your question. So hands-on will be part. We will be deploying containers. We will have a microservices. We will deploy containers. It will be running because we can create multiple applications, full-fledged. Let's say WordPress along with MySQL. WordPress application, if you have heard of WordPress, very popular application for a website. It also has the MySQL. So we will create a WordPress application where you will have WordPress running as one of the containers and it's interacting with MySQL container. So it's a full-fledged application that we're gonna deploy. Similarly, you can deploy other kinds of applications also, Ruby applications, Python applications. Once you know how do we work on it, you can deploy other kind of applications. I'm going to also talk about other things. I'm going to give you the code of deploy other things. We deploy using Docker Compose, using YAML file, right? We will full-fledged application is what we will deploy. On Kubernetes, same thing. We will deploy a full-fledged application. We'll deploy pods. First of all, you need to understand what is pod, what is replica set. First, you need to understand the basics, the language, ABCD. Then we'll talk about sentences. Then we'll talk about writing one book, right? Those kind of, so we'll take things slowly. So full-fledged application using Docker, using Kubernetes is what we will deploy. And then how do we monitor it? Once we have deployed the application on the server, on the containers, on the pods, how do we monitor it? So it's a full-fledged thing.
Right. Thanks.
Sure. Does it support across technology platforms? Linux. If you're talking about operating system, Hanuman, mostly Docker Kubernetes works on Linux. They don't work on Windows, right? So we will take Linux example, Linux VM, virtual machines, and we will deploy things. We'll use AWS cloud. Need you to have fundamental understanding of cloud. We will create EC2 instance VMs, that's called VM, and then we will create Docker application. We'll deploy that. And for Kubernetes, we'll talk about EKS. It's a managed service. We will talk about manual installation also. You can install in a VM, but every company uses a managed service. EKS. We'll take EKS example. We'll create cluster. That cluster will create multiple worker nodes, one master node and multiple worker nodes. When I say worker node, two VMs. Worker node is nothing but a VM. And then we can deploy your applications. And whatever we're talking about, all those features, auto healing, auto scaling, all these things, for all these features, we need Kubernetes objects. So we need to deploy that as well. Because we don't get these features without automated. You need to deploy things along with the pod, along with the container. Your main application, you need to deploy other objects also to enable you with these features. Auto healing, auto load balancing. So we need to deploy that as well for your application. Then these things gets enabled. So it's going to be on Linux and EKS. Again, for Prometheus-Grafana, we will install in Kubernetes EKS only. We'll use a Helm chart, right? And we will install things there only in the cluster, Kubernetes cluster, and monitor things. I'm not sure if you know about Helm chart. So Helm chart is a Kubernetes package manager, Helm. If you need to install anything in Kubernetes cluster, we use Helm charts. So we have charts for Prometheus and Grafana. If you go to the charts, you need to search for packages, Prometheus, Grafana, and we need to install these things. So this is the Helm chart for Prometheus. Similarly, if we have Grafana, we need to run this, install this. So we'll install this using Helm chart. It's a default package manager, very popular one. Hanuman, I hope I answered your question. Okay. Anybody else? Other questions?
If we use Kubernetes, still do we use Docker to create containers? Because to overcome the Docker features, so we have Kubernetes. So do we still use?
You cannot compare Docker and Kubernetes. The use case is different, right? One creates container. So even for Kubernetes, you need a container engine. Kubernetes is container orchestration engine. It has these features, but these features we need with containers only, right? So container orchestration engine uses container engine to create containers. So don't think you will compare Docker with Kubernetes. No, Docker has some use case to create containers. These features not possible with Docker. If you want to compare Kubernetes, you should compare with Docker Swarm. Docker family has one more product called Docker Swarm, which is not that popular. Docker Swarm is a container orchestration engine. So if you want to compare Kubernetes with Docker Swarm. So Kubernetes will use a container engine. Docker or container D. We have different kinds of more popular container engine also. Don't think uses. Okay, so don't think Docker is the only container engine. No, Docker is one of the container engines. Docker is popular, the most popular container engine. But we have other container engine also, like container D, very popular. In fact, when I create EKS cluster, by default, they give us container D. They don't give us Docker. But the concept remains the same. You have Podman. We have a lot of other important container engine also. So Kubernetes will use a container engine. Mahadev, you got this?
Yeah, got it. Yeah.
Don't compare Kubernetes with Docker. No, it's unfair on Docker. It doesn't. That poor guy doesn't have those features. Simply, so you can't compare. So
Yeah.
it will. This guy will
So,
use. Yeah.
so mainly Docker will use for to create the container, and Kubernetes for handling these advanced features like scaling.
Exactly. 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 And Kubernetes will use a container engine because these features we need for containers only, right?
Yeah.
And without container engine, we cannot create containers. So if you look at the architecture also, right, let me show you one of the important things. If you look at the Kubernetes architecture also, if you look at the Kubernetes architecture also, you will find a container engine installed. So this is the Kubernetes architecture. What do you think? Docker is installed in a worker VM to create containers. Able to
Yeah.
understand this, Adev?
Yeah. Yeah, got it.
Yeah.
And
Good.
these cloud vendors, right? They have their own monitoring tools. So why we, going for
Okay,
Prometheus?
this EKS you're talking about?
Yes.
Oh yeah, we will talk. If you're interested, I can demonstrate container insights also. It is an open source tool, so I thought MicroServices would add a lot of value. Container
Okay.
insights I can show
No,
you.
no,
So if you
no.
if
My
you if
question
you
is
Hmm.
like we have CloudWatch for AWS, right? Like
Correct,
that we
CloudWatch
come.
container insights. Correct. That's what I'm talking about. That's what
Okay.
I'm talking
Then
about.
why do we use Prometheus and Grafana?
It's
We can
open
use.
source. Open source. This guy will cost a lot.
Oh, okay.
See, we have container insights, right? In fact, in the course, in the PPT, usually I talk about container insights only. If you come down for the monitoring part, I talk about container insights only. I can talk about that. I'll take up both container insights along with Prometheus-Grafana. I'll take up both. So it will add value to your resume. If you know an open source tool, right, it will add a value. People would like to do the cost optimization using some open source monitoring tool. That's why we have put this in the course. So I'll take up both container insights as well as Prometheus-Grafana. Sounds good?
Sure. Yeah. Yeah. And are we covering anything like, real world case scenario for SR use cases like, where container CPU is going high and how to drill down for exact root cause for the high CPU
See, once
or
you understand the basics, right? See, first of all, that's another level. First, focus on the learning things, right? Then you go troubleshoot. Eventually, we know. If once you know the basics, then you'll get the understanding. You need to check the logs, how to check the logs. I will talk about that. But you should
oh,
have
okay.
the understanding of what to check, where to check, right? What to type. So we will talk about that. So that's what troubleshooting. So troubleshooting is the next step. Once you know the basics, and we will talk about that. And you can
Yeah.
ask me questions. Once you understand the basics, then you can ask me more questions if you have from your working experience as well. You can ask questions.
Okay, sure. Yeah, thank you.
No, Hanuman. DevOps experience to create Docker Kubernetes. See, when you say about DevOps, DevOps is a bigger thing. Okay, it's a umbrella. It's a bigger domain. Docker Kubernetes is a part of DevOps. DevOps is a much bigger thing. DevOps talks about dev and ops, how developer and operations interact. That's what DevOps. This is a part. If a developer working on Kubernetes, it's a part of DevOps. So it's a subset of DevOps. Kubernetes and containers and Docker and Kubernetes. It's a subset of DevOps. Okay, guys. So that is all from my side today, guys. Please take a call. I hope you got a better understanding of this course and what is gonna add value to your skill sets. You can decide now, and you can join tomorrow as well. Okay. We are gonna continue. So all those discussions starts from tomorrow. All the things that we have talked about today will start from tomorrow. So tomorrow we'll talk about catch, what is Prometheus, what is microservices, what is monolithic. I'm going to repeat those things in a much sequence manner. Today I have just jumped right Docker, Kubernetes, Prometheus, just because of demo. I want to give you a full view of the course, but from tomorrow we will go in sequence. Okay, same timing. 7:30. 7:30.
So anything are we covering, some of the features like from Azure or GCP or only AWS?
See, we can cover Mahadev, but course will become 40 hours.
Oh, okay.
So we are not covering. So course is for 20 hours. If it's somebody will talk about why not Azure, why not OCI.
Yeah.
There's gonna be never ending things, right? So once you know one service provider, you can learn others.
Okay. Yeah.
Okay, so timing would be 7:30, Hanuman, 7:30 p.m. Yeah, Wahid, go ahead.
So do you have a course like, like A to Z, like where, I spoke to you earlier about the pipeline and everything, like, so because I have my own, like a small software where I just want to make sure that, my developers and everyone, and this like proper pipeline for the software, the one as I explained you earlier, and then can be loaded up into AWS or, XYZ servers.
I got your question. See, I have a course. Okay, I have a course to answer you. That's a much full-fledged course that I have. Okay, SRE course with Isa only we have. So you can take a look about this course. It's gonna be 50 hours course and be a lot of details. Okay, so you can take a look of this.
Okay.
I'm gonna share the link.
Okay. But I think the timing was really a bit difficult because I live in UK and I think this one is starting 5 o'clock in the morning. Oh, sorry, is it 9 o'clock in the Indian time? Let me see one.
Right now we started at 7 p.m.
In the evening.
In the evening IST, yes.
Yes, and it started already or?
Yeah. Right now it's 8:05 p.m.
Okay.
8 p.m.
So okay, understood.
This course has already started. So you need to enroll in the next course only.
Okay.
So this course has already started. We already started a month back.
Okay. Yeah, that's fine. I'll take this one.
Yeah. Okay. Thank you so much, everybody. We will meet tomorrow and all the very best. Thank you.
Thank you so much. Thank you. Bye.